Hello and welcome to the Algebra 1 Test 3 study guide. My name is Mr. Sipple and I will be your guide through the next 10 problems. You'll notice on your page that there are 3 columns. The 3 columns across the page, number 1, 1, and 1, they're really all the same problem, just slightly different numbers. So what we'll do is I'll work through the left column. I'll model that problem for you. I'll show you how to do it, and then we want to give you an opportunity for you to try it to make sure that you understand what you're doing. So after I finish the problem on the left side, you'll pause the video, try the problem in the middle, try the problem on the right. At that time, you'll go ahead and hit play. I'll give you the answers for those 2 problems. Now, I won't have them worked out, but I will have the answers there for you so that you can check your own progress. If you have both the answers correct, wonderful. Go ahead and go on to the next problem. If you don't, however, that's okay. Take a moment, see if you can, first of all, before you ask for help, see if you can work through and figure out the mistake that you made. And if you're still unable to figure out maybe where you went wrong, then go ahead and pause the video, raise your hand, and we'll get some help to come around to help you with whatever you got wrong on that problem. Alright, so before we get started, let's start by putting our name on our paper. So, top right hand corner, go ahead and put your name. And then under period, because some of you are coming from different teachers, and I don't necessarily maybe know which teacher you're coming from, I want to make sure you get credit for being here and for doing this assignment. And so we want to make sure that this work gets into the right hands. So under period, if you would go ahead and put your teacher's name. All right. And then before we actually get into the first problem, there's just a couple things that I want to kind of set up for us. And if you notice on the top left-hand corner, I left a little space. What I'd like you to do is I'd like you to copy down what I have here for us. And you'll notice that it says Solving Equations Checklist. Now this checklist is going to be the same thing that we use for inequalities. You'll notice that actually what we're looking at on this study guide is inequalities. But you know what? To solve an inequality is really the same thing as to solve an equation, except there's one little thing that's a little bit different. We'll talk about that in a little bit. First thing I'd like you to write down, though, on our checklist is that we always want to check to see if there's parentheses. So if we see parentheses, parentheses means to multiply, so we're going to want to distribute. After we check for if there's any parentheses that we need to get rid of by distributing, we want to see if we want to combine any like terms. So like terms are same number with same number, or maybe same variable with same variable, and so we'll see those in a couple of the problems. After we've combined like terms, we want to make sure that all the variables are on the same side. Remember, the goal of solving an equation or an inequality is to isolate. Isolate means to get by itself, so we want to isolate the variable. We want to get it by itself. Well, to do that, if you have variables spread out, we want to get them all in the same location first. And then after we do that, we always add or subtract first. So if we have some numbers that we're going to need to get rid of, we always do addition or subtraction first to get rid of those numbers. And then whoever's still hanging out, we're going to multiply or divide those last numbers to get rid of them. All right, so that's a checklist that we're going to keep referring to. So make sure you have that written down on the top left-hand corner of your page. If you haven't written that down yet, go ahead and pause the video here to make sure you have that down. Otherwise, let's just go ahead and jump into it. First problem, and actually the first couple problems that you'll see on here, these problems are, I think, a little bit easier, you know, because you don't actually have to solve the whole problem. If you look down at the multiple choice, A, B, C, D, you see that it doesn't say x less than 5, or, you know, it doesn't give you a specific answer. It's just like they kind of did part of the problem and then they stopped. So what we have to do is just see what we can do and then see which one of those answers matches up with what's below. Well, first thing on our checklist is to distribute with parentheses. So I do see parentheses. I see some parentheses here, and I see parentheses here. So what I want to do there is I want to distribute. Distribute means to multiply. So I circle the number that I want to multiply, which in this case would be 4. And I'm going to draw an arrow to where it is I'm multiplying, because I want to make sure that I multiply both of the numbers. Not just one of the numbers, but both of the numbers. And what I mean by that is this is a very common mistake. We do 4 times x, so we get 4x. We're good there. But then what we forget to do is we forget to multiply the second number. Now, by the way, don't write that down. That's not correct. I'm going to fix that here in a second. But so this is a common mistake. We do 4 times x, 4x, but then we forget to multiply the second number. So that should not be 4x minus 2. Let me get my eraser. Should not be 4x minus 2. Should be 4x minus 8. Right. And remember, when you multiply, if the signs are the same, you get a positive. If the signs are different, it would be a negative. All right, then let's carry on with the rest of the problem. I do see another set of parentheses here. So I'm going to take this 6, circling it, drawing my arrow. And so 6 times x is 6x. 6 times 3, which would be a positive 18. And I know for some of you, you may not have all of your times tables memorized. So just keep in mind that multiplication is really just repeated addition. And what we mean by that is that 4 times negative 2, for instance, right? What that means is that it means to take negative 2. So let's say I wanted to say negative 2 times 4, right? What that means is to take negative 2 and add it 4 times. Well, negative 2 plus negative 2 plus negative 2 plus negative 2, 2, 4, 6, 8. And they're all negative, so it would be a negative 8. 6 times 3, and again, let's say you didn't have that memorized for whatever reason. Or we have some memorized, but then sometimes we kind of tend to forget things. What that means is that it means take 6 and add it 3 times. Well, so 6 times 3 what that really means is 6 plus 6, which is 12, plus another 6, which is 18. So I always say that with multiplication, if you don't have your times table memorized, that's okay, as long as you can skip count, right? So for instance, counting by 6s, 6, 12, 18, that's skip counting. You could still come up with the correct answer. All right, and then let's come back to our problem. And I've got 4x minus 8. Let me look at A. So they've got 4x minus 2. Well, it's not that one. And one test-taking strategy that I like to use is I like to cancel out the part of the answer that makes the whole answer wrong, meaning that this really should be 4x minus 8, not 4x minus 2, so I know the answer is not A. I look over at D, I see the same thing, 4x minus 2. I'm like, well, it's not that. Now, between B and C, they both have a 4x minus 8 and a 4x minus 8. Let me look at the rest of what I have here. I've got 6x plus 18, 6x plus 3. No, it's supposed to be 18. And then, oh, there's my 18. So the answer would have to be C, right? And the reason that I went through that, and you might have thought like, well, that's easy to kind of pick out and see. The reason why I went through that really slowly, though, and carefully, I should say, is that because if you look at it at first, it looks like all of these answers kind of look the same. So that's where you have to really look closely at it to make sure that you find the answer that matches up with your answer. All right, well, that was the first problem. So what we'll do at this point is go ahead and pause the video. Try number 1 in the middle. Try number 1 on the right side. Once you have those two complete, you feel like you've got an answer, go ahead and hit play, and I'll tell you what the answers were, and then we'll check them from there. All right, so go ahead and pause the video now. Welcome back. Let's see how you did on those two problems. For number 1 in the middle, should have got a correct answer of D. And number 1 on the right side should have got a correct answer of B. So again, if you got both of those correct, awesome. Go ahead and let's go ahead and go to the next problem. If not, pause the video here. And again, before you ask for help, let's see if you can take some time and figure the mistake out on your own. To be honest with you, I'll tell you right now, a lot of times what people do is that they, as we mentioned a little bit earlier, you'll multiply the first number, but then you'll forget to multiply the second number. Or you'll make a mistake with the sign. So go back and look at your multiplication, and go back and look at to make sure that you got your signs correct when you did multiply. Otherwise, let's take a look at number 2. All right, so number 2 is a very similar problem. You notice that the answer is not, if you look at A, B, C, D, you notice it's not solved all of the way. So this is one of those problems where they just want us to do a step or two and then compare our answer with what they have. Now, we're still going to run down the checklist in the same way that we have. So we're still going to start by distributing if we have some parentheses. I do see parentheses. I see some parentheses right here. All right, and as we said, what we want to do is we want to take the number that we're distributing and put a circle around it. So do that now. Take your pencil and let's circle a -3. And I emphasize that's not a +3. That's a -3, right? So if we multiplied by a +3, we'd end up getting an incorrect answer. So we want to make sure that we get signs correct on that. Let's draw our arrow. So that's going to be -3 times 8x, and then that's going to be -3 times 2. And let me write what I've got here. So I've got 6x. We haven't done anything with 6x yet. -3 times 8. Well, so that means if we counted by -3 8 times, -3, -6, -9, -12, -15, -18, -21, -24, right? So if we did that 8 times, we'd be at a -24. And since there's an x on there, we'll throw the x on there, -24x. And then -3 times 2, well, that means take -3 and add it twice. -3 plus -3 would be a -6. What's the rule? Remember, the rule is when you multiply, same signs positive, different signs negative. But we don't want to be solely dependent or only dependent on rules. We want to understand why we're doing what we're doing. All right, I don't see my answer quite yet because I've got 6x minus 24x. They've got some -18x's down here, so I'm thinking I have to do something else. So let's go to the next step on our checklist, which is to combine like terms. Now, when we say like terms, we're talking about, are there some numbers that you can put together, or are there some variables that you can put together? In this case, our variable, we're talking about x, and so we say, okay, well, there's some x's we can put together. Well, I do see that there are some x's that we can put together. So, for instance, if I took a positive 6x and a negative 24x, and I put those two together, how much would I have? Well, when we think about positives and negatives, when we're adding, I encourage you to think about points. And this is something you'll hear us refer to, the positive team, the negative team. What I mean by that is that we've all had a circumstance where we played a game, either a board game, card game, sports, some sort of game where you have to keep points of who won and by how many. So think of there being two teams. There's a positive team and there's a negative team. And then we ask ourselves, okay, well, the positive team scored 6 points. The negative team scored 24 points. So then if I then asked myself the question, who scored more points? Well, I would say the negatives did, right? Because the negatives, they scored more points. So if they scored more points, that means, well, they won. So the answer would be a negative. And then I asked myself, okay, well, how many did they win by? If they scored 24, they being the negatives, and the positives only scored 6, then we have to find the difference between those two numbers. Difference meaning subtract. So 24 minus 6, take 6 away from 24, which would be 18. So that means the negatives won, and they won by 18. And then I'm just going to bring down the rest of what I have here. So I've got a -6. And again, I didn't combine these two guys because, well, that's an x and that's a number. So those are not like terms. You might also wonder, hey, what about the 15x? He's an x. Why didn't you throw them together? Well, the thing is that if you notice, the x is on the other side of the inequality symbol, right? So it's separated from these two. So that's why I was not able to combine those two things. All right, so now that we made that move, let's check down and see if we have our answer somewhere. So I see -18, -18, -18, -18. If I look at D, however, D says a +14. So I know that my answer is not going to be D. Let me check through the rest of these. -18x -6. All right, I see a -6. I'm thinking A is probably going to be my answer, but let me rule out the rest of them. -6, not a +1, not a +6. So my answer would have to be A. All right, same procedure as the last one. Go ahead and pause the video at this point. Try number 2 in the middle. Try number 2 on the right side. And we'll be back in a moment to see how you did. welcome back. Let's check your answers for number 2. Number 2 in the middle should have got A for that problem. And for number 2 on the right side should have got an answer of D. So again, if you got both of those correct, wonderful. Let's move on to the next one. If you did not, let's pause it here. Try to figure out your mistake first. Again, check your signs. Make sure you multiplied correctly. A lot of times it's little stuff in math that gets us. So check those things first before you ask for some help. And if you still can't figure out what mistake you made, then certainly let's go ahead and raise your hand. Otherwise, let's go ahead and go on to number 3. So number 3, those first 2 problems kind of built up to this one. The first problem, we just kind of had to do one thing on our checklist, and then bam, we were done. That last problem, we actually had to do 2 things on our checklist, and then we were done. And so really this one kind of then just builds one more little step on that one, which is where we're actually going to have to do 3 things on our checklist. But same idea. If you look down there at ABCD, you see that it's not actually solved all the way, so that's okay. We don't have to solve it all the way. They just want us to go through the first couple steps. So we know that by now our first step is we're always looking for parentheses to see if there's any distributing that needs to take place. I do see some parentheses right there, so I know I'm going to have to distribute. So let's take that 3, and again I'm circling it. And make sure you're doing these things, right? So one of the things that we want to make sure we're doing is that we're interacting with our work to making sure that our head's in the game. So don't just watch me circle this 3. You circle it on your paper as well. Don't watch me just draw this arrow. I want you drawing this arrow, right? So the idea is that the more engaged you are with your work, the more you're into what it is that you're doing, the less likely you are to make mistakes, and hopefully the more likely you are to understand. All right, 3 times 4, well, that just means take 3 and add it 4 times. 3, 6, 9, 12. So 3 times 4 is 12. And both of those were positive, so I didn't have to worry about any signs. 3 times negative 5x. All right, so what that means is we're going to take negative 5 and then add that 3 times. Negative 5 plus negative 5 plus negative 5, which would be a negative 15x. And let's copy the rest of what we have here. So we've got less than or equal to x plus 7. All right, so next thing on the list is to combine like terms. Now, I have numbers, but they're on different sides of the inequality symbol. I have x's, but they're also on different sides of the inequality symbol. One strategy that we can always employ, one strategy we can use, is that the inequality symbol, or the equal symbol, it's kind of like this barrier that divides the 2 sides of the inequality. So this is where I can clearly see that these are on different sides. So I cannot combine them in the same way that I did the last problem. So, for this particular step, nothing I can combine. So I've got to move to the next thing on the checklist, which it says move all the variables to the same side. So I'm going to move all the variables to the same side. Now, it doesn't matter which side you move. If I wanted to move x over here with negative 15x, I could do that. If I wanted to move negative 15 over at the x, I could do that as well. Which one do you do? Well, this is one of those kind of use the test to take the test moments where you look down at the multiple choice, look down at A, B, C, D, and see how they have their answer. So you notice how they have their answer. All of their x's are on the right side of the inequality. Well, what we're trying to do is get our answer to match theirs. So let's move all of our x's over to the right side. So now, how do we move something? Well, in algebra, we always do the opposite to move things. So the opposite of a negative 15x, or of subtracting 15x, would be to add 15x. So we're going to add 15x to both sides. And then what ends up happening is that those 2 things cancel out, which is what we wanted to happen. And then I'm going to bring down the rest of what I have. I've got 12 less than or equal to. And then, so x plus 15x, well, how many x's would that be? Well, let's think about it. If I had 1x, and now I've got 15 more of them, that means I have a total of 16x. And one thing you might want to do, see, there's really a 1 in front. That's really 1x. So the 1 plus the 15 is where we're getting the 16 from. And then we'll do a plus 7. Okay, so I've got 16x. they've got 16x. Of course, they got a 6x over here, so I'm thinking A and C are probably not the correct answers. But they've also have 16x by itself on the right side. So, and I look at what I've got, and my 16x still has a number that's over there, this plus 7. So what I'm going to want to do is I'm going to then get rid of that plus 7. And by the way, we can check this off that we moved all of our variables to the same side. Now, actually, the next thing on our list says to add or subtract. So if you're still trying to get if you're trying to isolate a variable, you're trying to get it by itself, then we want to add or subtract to do that. Well, so that's a plus 7. So then the opposite would be to subtract 7. So we're actually going to subtract 7 from both sides. Right? Because we have this golden rule in algebra. What you do to one, you do to the other. So if I'm subtracting 7 there, then I also then need to subtract 7 from the other side as well. Well, 12 take away 7, that would give me 5. And then I'm just bringing down the inequality symbol, less than or equal to, less than or equal to, and then 16x. So if I look at the answer, now this is where these people are tricky. You got to be really careful, because if you look at B and D, you're like, well, hey, they pretty much look the same to me. Well, but let's look at it. What is the difference between B and D? Well, the numbers are the same, 5 and 16x, 5 and 16x. The only thing that's different here is the symbol. See, that's a greater than or equal to. You see, that's a less than or equal to. Well, my symbol is a less than or equal to, so I know that that would have to be the answer. So our answer there would be D. So be really careful, and maybe I'm going to even get my highlighter out here for a second to highlight the difference there, right? That's a less than or equal to, so I wanted to pick the answer that also had a less than or equal to. All right, well, let's go ahead and pause the video at this point and try number 3 in the middle and number 3 on the right side. All right, math fans, welcome back. And let's see, because you are a math fan, right? I don't know, you maybe don't think you are, but no, you are a math fan. You're a big math fan. Let's take a look at number 3 in the middle there. You'd get C, 2 less than or equal to 13x. And number 3 on the right side would be D, negative 2 less than or equal to 19x. So again, pause it here if you didn't get them correct. If you did, then let's move on. So number 4, some words. I know we always get a little freaked out when we see some words, but I promise you this one's not as bad as you think it would be. And in fact, I would actually argue that you could probably solve this equation right now without writing a single thing down on your paper. If I told you that you had $50 to spend at the Ventura County Fair, so you're going to the fair and you got $50 to spend, and then it's going to cost you $10 to get in. So then you're thinking, okay, I've got 50, now I spent 10 to get in, and then it says ride tickets cost $2, and then the question is how many tickets can you buy? I bet you if you just thought about it for a second, you'd probably be able to come up to the answer to this question mentally without writing a single thing down. You have 50 to spend, you spend 10 bucks, right? So now you're at a certain dollar amount, and then you have tickets that are $2 per ticket, and then the question is how many tickets can you buy? Well, I bet you're able to actually come up with that answer mentally, maybe, right? So the answer actually is going to be 20, but we actually want to kind of show that out, right? So what we're saying here is that you've got, it's 10 bucks to get in, plus $2 for each ticket. Now we don't know how many tickets that we're going to buy, so we'll do T. And so what we're saying here is we're saying T is equal to the number of tickets. And we could have used X or Y or any other letter, but you know, so if we have a choice of picking our variable, why not pick a letter that matches with the problem that we're doing? So since we're talking about tickets, we'll do T. And what we have to do is that we have to spend, well, I don't know, what do we have to spend? Do we have to spend exactly $50? Could we spend more than 50? Well, no, it wouldn't make sense to say more than 50 because you can't spend more than what you have. So then we'd have to spend less than 50. But if we wanted to, right, you think about when you have money to spend, you could spend your whole budget, right? So you can spend the whole 50 bucks if you wanted to. So what we'd want to do is we'd want to spend less than or equal to 50. Now, we haven't mentioned this yet. We're fourth problem in, but we haven't mentioned the inequality symbols, and that's maybe one thing we should go ahead and take a moment to do now. You know, sometimes people forget which one is which. So remember that symbol right there, and don't worry about Pac-Man or alligators or who's eating who. I want you to think of it this way. What letter in the alphabet does that look like? Well, you know, the top part kind of fell over a little bit, but that looks like the less than symbol. Or the letter L, I should say. The less than symbol looks like the letter L. So that's one good way to remember which one's less than and which one's greater than, is the less than symbol looks like an L. Now, by process of elimination, you would have to know, well, then, duh, that's the greater than symbol. But what's another way that you can remember that? Well, there's another letter that looks like. And you might say, oh, that doesn't look like any letter in the alphabet. Well, you have to use your imagination a little bit. But if we used our imagination a little bit, we'd see that that looks like a G for greater than. So less than, greater than. That's a good way to remember that. So coming back to our problem over here, the amount that we spend has to be less than 50, not equal to 50, not more than 50. It has to be less than 50. But again, if we wanted to spend the full $50 because we're feeling like we're a big baller and then we want to spend it all, then it would be less than or equal to. So that's why we use that symbol. So sometimes students don't understand, well, why do sometimes you see the line underneath, sometimes you don't. Well, this is the reason why, is that you want to include that number. You want to say, I could spend 50, but also I could spend less than 50. All right, so now as far as kind of running down our checklist, I don't see any parentheses, nothing to distribute. Combining like terms, that's a number, that's a variable. These are on different sides, so I can't combine the 10 and the 50, so no like terms to combine. I want to move all the variables to the same side. I actually only see one variable, just the t, so there's no variables to move. Okay, well, this is easy. And by the way, I should make one note on my t, is that don't confuse the plus sign with the t. If you were going to use a t, as I put a little tail on it to differentiate or to be able to tell apart the plus sign from the t. All right, we're going to add or subtract first. So if I wanted to look at, and again, this is my little barrier that splits the two sides of the inequality. If I wanted to get t by itself, I've got two numbers I've got to get rid of. I've got to get rid of a 10, and I've got to get rid of the 2. I don't care about 50. 50 is on the other side of the inequality, so who cares what 50 is doing over there? So I want to get rid of the 10 and the 2, and then the question becomes, well, which one do I get rid of first? Well, we always add or subtract first before we multiply or divide. So I know that I'm going to have to divide here because, see, really what that says, really says 2 times t. And so the opposite operation, how we undo multiplication, is we divide. So I'm going to have to end up dividing there, but that's what I divide last. So we're going to look at the 10 and we're going to say, oh, okay, I just need to subtract that. So let me go ahead and subtract 10 from both sides. And again, I'm subtracting because that's a positive 10. So the opposite of positive 10 would be a negative 10, or to subtract 10. And then again, our golden rule, what we do to one, we do to the other. So let's bring down what we have here. So we've got 2t less than or equal to 50 minus 10, which would be 40. And now we're going to go to the last part of our checklist, which is to multiply or divide. So that, again, we already said that says 2 times t. And again, we know that because anytime in algebra we see two things next to each other like that, and there's not a symbol that's in between them, because if we were adding, there would be a plus in between or a minus in between, or a division symbol like a bar. But here there's nothing in between, so then that we know that means multiplication. So I would divide both sides by 2, and I would get that t is less than or equal to 20. And that should make sense because what we're saying is that the number of tickets, t, that we can buy is less than or equal to 20, because we could buy 20 tickets if we wanted to, or any amount less than that. Now, I said at the very beginning of this problem, you might have solved this problem 5 minutes ago in your head, because you said, you know what, if I had 50 bucks to spend, and then I spent 10, now I'm down to 40, and if I've got 40 bucks to spend on tickets, and tickets are $2 a piece, then 40 divided by 2 would be 20, and you would be correct. So that's a very good example of where you probably just did a two-step inequality in your head, You didn't realize that's what you did. So this is a very good example of the math that we do. We don't necessarily realize that we're doing. So you have to give yourself a little bit more credit in realizing that you do and can do more math than maybe what you realize. Alright, so number 4 in the middle and number 4 on the right side is for you to try. So go ahead and pause the video and we'll check back with you here in a second. Okay, well, let's check those answers for number 4 in the middle and number 4 on the right side. So for number 4 in the middle, should have got t less than or equal to 25. Pretty much the same problem. We just changed the amount of money that you have to spend, and otherwise pretty much the same problem. And then number 4 in the middle, same idea. We pretty much just changed your budget. So instead of $60 or $50, we're saying you've got $30 to spend. So should have got t less than or equal to 10. All right, well, congratulations. You made it through the first half. Now what we'll want to do is go ahead and turn it over to the back side, and we'll take a look at the back half. So number 5 says Eddie needs to take a taxi, charges a flat $2.75 for getting in. When we use that word flat, we're not meaning flat like a pancake. What we're meaning is that it's kind of a fixed cost. So, you know, regardless of how far you're going to go in this taxi, just for getting in the cab, they're going to charge you this $2.75. So it's almost similar to the fare problem where we say they charged you $10 to get in, so it doesn't matter how many rides you go on, you got to pay that $10 regardless. So it's kind of the same idea with this. Is this $2.75? You got to pay that regardless of how far you go. And then it says that it's going to be $1.50 for each mile, right? Because they charge you for each mile that you go. And then we've only got a total of $11.75 to spend. And then the question says, how many miles can we travel? Well, so if we're looking for how many miles, right, how many miles can he travel, then what we want to do is we want to figure out, okay, if I've got $11.75 in my pocket, and they're going to charge me $2.75 just to even get in, and they're going to charge me $1.50 per mile, how far can I go? So it's kind of the same idea as the fare, where you had a budget, you had so much money to spend, they're going to charge you something up front, and then they're going to charge you you know, and the fare problem was tickets. In this case, it's miles. Well, so let's go ahead and begin to write our equation. Similar to what we said in the fare, we started with by saying, well, what are they charging us up front? Well, they're charging us $2.75 up front, plus $1.50 for each mile. And I'm just going to do M for mile. And that has to be less than or equal to $11.75. And again, the reason why it's less than or equal to, similar to the problem previous, was that if you have a certain amount of money to spend, you can't spend more than what you have, so it couldn't be greater. You have to spend less than what you have. But you also could spend that whole amount as well. All right, and by the way, we're using M. M is going to represent the number of miles. M is number of miles. So let's go ahead and get M by itself. And what we want to do is we want to get rid of the $2.75 first, because I know that I can skip the first couple things on my checklist because I don't have any parentheses. I do not have any like terms to combine. I do have all my variables on the same side because I actually only have one variable. It's just M right there. And then so I just want to add or subtract first. So that's a positive $2.75, so I'm going to subtract $2.75 from both sides. So let's do a minus $2.75, minus $2.75. Actually, let's extend that line all the way across. And the 275s cancel. Got a $1.50 that we're going to bring down, less than or equal to. And I know a lot of us have a little decimal phobia, so let's just slow it down. 5 minus 5 would be 0. 7 minus 7 would also be 0. Bring down the decimal. And then 11 minus 2, which would be 9. So that's where we would get $9. Okay. Now, M is still not by itself. We need to get the M by itself. So what we want to do is that says 150 times M. So the opposite of multiplication would be to divide. And maybe another way to think of this is to say 150 times what will make 9. And before I even show this by dividing out the decimal, let's just see if we can figure this out. So if I wanted to say 150 times what number would make 9? So what I'm saying is that if I did 150, how many times would it take me to get up to 9? So if I did 150 once, well, okay, I'm at 150. If I did 150 twice, now I'm at $3. If I did 150 3 times, now I'm at $4.50. If I did 150 4 times, now I'm at 6. If I did 150 5 times, and I'm just doing a little tally over here, then I'm at $7.50. And then if I did it one more time, then I would be at 8. Right? So, or I'm sorry, then I would be at 9. So that's maybe another way to kind of think of this, is that what we ended up doing, and that ended up being, 6 times there. So I did $1.50. So I did $1.53, $4.50, 6, $7.50, 9. So that ended up being 6 times. So that's a way. I know sometimes we're afraid of decimals. That's one way you could have figured it out without having to, do that whole thing out there. But let me show you this way too. So we'd end up having m is less than or equal to. We already know the answer is 6, but let's just see what that would look like. So I'd actually kind of go to the side, do a little scratch work here. So we'll do $1.50 into 9. You know that when you divide decimals that you have to move the decimal all the way over? So that's really how many times does 150 go into 900. And so one thing that you can kind of do with that is you'd say, well, I'm not sure. Well, and then you kind of pick a number and you say, I don't know, maybe it goes in 7 times. Now again, we're pretending that we don't know. We actually do know what the answer is. We know it's 6. But I'm just saying, let's pretend we don't know. How many times does 150 go into 900? And you're like, I don't know, let me try 7. Right, so let's just say we tried 7 and we try to multiply this out. Alright, so 7 times 1 would give us 7. Let's add 3 to that, so that would be 1050. And you're like, oh, that's too much. I went over. So maybe it's 6. Let me try 6. So 150 times 6, which would be 900. So the answer there would be 6. So I just show you that over here to show you that, sometimes we do a little trial and error. We don't have to know exactly what the answer is, maybe. Maybe we do a little trial and error. So that would be m is less than or equal to 6 miles. So that means that we could go up to 6 miles in that cab. Don't have to go the full 6, but we could go up to it. Alright, so let's try number 5 in the middle and number 5 on the right side, and we'll check back with you here in a second. Welcome back. By the way, if you got the same answer for number 5 in the middle as number 5 on the right side, you didn't make a mistake. Really kind of a coincidence. The answer to number 5 in the middle was 5 miles, and the answer to number 5 on the right side was also 5 miles. So that was not necessarily done intentionally, so purely coincidence. Don't read too much into that. Alright, so again, pause it if you need some help with that one. Otherwise, we'll go ahead and take a look at number 6. Alright, so number 6, and actually through the rest of the study guide here, are some pretty much just straight up, just solve it. Right? So no word problems. Not like the first couple problems where you just had to do a couple steps and then move on. So this is pretty much just straight up solve it. So we're going to start with our checklist at the very top. And we're going to distribute with those parentheses. So I do see parentheses. I see a set of parentheses right there. So I'm going to take the 3. I'm going to circle it. And I'm going to draw an arrow to where I'm distributing. So 3 times x, which would be 3x, and then 3 times negative 6, which would be a negative 18. Remember, when the same sign's positive, different sign's negative. Or another way to think of that is to take negative 6 and add it 3 times. Negative 6, negative 12, negative 18. Right? And then we'll copy everything else that's down there. So let's just bring everything down. Because, by the way, I treat solving equations and inequalities, I treat it like a game where you can only make one move per turn. So you make your one move, and then you wait for your next turn to make another move. So my one move in this turn was to multiply or to distribute the 3, and then I brought everything else down. And now it's my turn again, so now I'm going to make my second move. I say that because I don't want you to try to do too much at once. Sometimes we do that. We end up making mistakes. Combine like terms. Let's see if we see any like terms here. I do see some like terms. I see a 3x and I see a negative 4x. And then so what I want to say is, well, if I put those two together, how many would I have? Well, we talked about earlier this idea of, points, who scored more. So let's look at it. So this says the positive score 3. This says the negative score 4. So if I said who scored more, well, the negative scored more, right, because it's bigger. So I know that my answer is going to be negative. And then if I said, well, how many more negatives do I have than positives? Well, if one team scored 4 and the other team scored 3, well, there's a difference of just 1, right? So then our answer would be a negative 1x. Now again, bring everything else down. I've still got this minus 18 right there that I'm going to bring down. And then less than negative 22. All right, so let's add 18 to both sides. And again, we're going to do that because we know that we add or subtract first. We didn't mention here move all the variables to the same side. There actually is only one variable, just this negative 1x, so there's not variables over here, so we could skip past that step. And then we're going to add or subtract. So let's go ahead and add 18 to both sides. So we're going to go ahead and do that. We're going to add 18 to both sides. What we do to one, we do to the other. Bring everything down, so I've got a negative 1x less than. And again, I got to be careful with my signs here. So I'm asking myself that same question. Who won and by how many? Well, the negative scored 22. The positive scored 18. So that means the negatives won. And if I said, well, how many did they beat them by? Well, I'm finding the difference between the two numbers. If you scored 22 points and I only scored 18, you beat me. And how many did you beat me by? Well, you beat me by 4. All right, so now x is still not by itself. You might say, well, it looks like it's pretty close, and it is. But you notice there's still a negative 1 here that we've got to get rid of. So what we have to do is that we always, again, we save that number that's right up next to x, that coefficient. Coefficients are fancy math word for the number that's with the variable. The coefficient, we always get rid of that last. So that's why we're multiplying or dividing last. So that'll be our last step on this one. So what we're going to do is we're going to go ahead and divide both sides by negative 1. And remember, you divide by the number you're trying to get rid of, right? So if we're trying to get rid of a negative 1, we'd have to divide by a negative 1, which would end up with a positive x. And see, I know what you're thinking. Let me kind of pause right there for a second. I know what you're thinking. You're thinking, wait, I thought the opposite of a negative 1 would be a positive 1. Well, see, here's the problem. If you did that, and let me just kind of erase this for a second. If I left it like that, if I said negative 1 divided by positive 1, well, what is a negative 1 divided by a positive 1? Well, a negative 1 divided by a positive 1 is a negative 1. So I'm right back to where I started. I didn't get rid of the negative 1. So the only way to really get rid of that negative 1 is to divide by a negative 1. So make sure you catch that. When we subtract, the opposite of subtraction is addition. So that's why those numbers are opposites. But when you multiply or divide, you divide by the same number. So that would be a negative 1. And then negative 4 divided by negative 1, signs are the same. So you'd get a positive. Now, you notice I left the middle blank there. I didn't put a symbol there yet. You notice what we've been doing on all these other ones is that if it was less than, we just brought it down. Less than, less than, less than. Well, so there's one little thing that's different with inequalities, and we said this at the very beginning of the video, that it's pretty much the same thing as an equation, except inequalities have one little thing that's different about them. If you haven't already written this down, write this down, this note down at the bottom of your page there. What we do is that we only switch the inequality symbol when we multiply or divide by a negative. I'll go ahead and highlight that there. So you switch the inequality symbol when you multiply or divide by a negative. So, and I know this is going to be, conceptually this might be a little difficult to understand, but what we're doing with this is that we're saying that if this less than would turn into a greater than. So my answer actually would be x greater than 4. And let me show you what happened there on that. Is that the less than, excuse me, less than would be turning into a greater than. Now, why did that happen? Well, because what we're saying is we're saying that x is less than a negative 4. But then what happens is that, okay, so we're saying x is smaller than a negative 4. But then it turns into a positive 4. So now we're saying because the number is switching sides on the number line, that value also gets switched in regards to the inequality symbol. So if the number is less than negative 4, now what we're saying is that's now switched so that we're saying x is greater than 4. So because the number switched sides on the inequality, the number line I should say, the inequality symbol switched as well. Alright, so let's go ahead and pause the video now. Same routine. Try number 6 in the middle and number 6 on the right side. Welcome back once again. Let's see how you did on number 6. Number 6 in the middle should have had x less than 5, and you would have had to switch the inequality symbol on this one as well. So that greater than would have switched into a less than. And on number 6 on the right side should have got x greater than 8. Same situation here. That less than would switch into a greater than. And again, if you're not sure about if you got the correct answer, or if you're not sure about, again, this whole idea of switching the inequality symbol, go ahead and pause the video now, get some clarification on it, and then we'll jump back into it. Otherwise, we'll go on and take a look at number 7. So again, 6, 7, and 8, you know, these next couple problems are, as we said, just pretty much straight up, just solve it. So if you look at number 7, I'm going to start with the checklist, distribute. If I've got some parentheses, which I do not see any parentheses, so I don't have to worry about that. Combine like terms, well, let's see. I've got some y's on the left side. I've got some y's on the right side. Remember, the inequality symbol here kind of divides these two sides. So there's nothing, I can't combine these two things. I can't say, oh, that's going to be a negative 10y. I can't combine those two things. So there actually are no like terms that I can combine. I want to move all the variables to the same side. So I do see this. I see y's over here, and I see y's over here. So I know that what that means is I can move all the variables to the same side. We said earlier, it doesn't really matter whether you want to move the variables to the left side or you want to move the variables to the right side. Doesn't make a difference. So just pick a side. So I'm going to move all the variables, I don't know, I'm going to move all of them to the left. And the reason why is that, you know, at the very end, you know, when we write our answer, you know, maybe just kind of look back there a second, right? You know how we always put the variable on the left side and then the answer, the number on the right side? See, variable on the left, number on the right. So you know how that, you know, that's the final answer is going to end up like that anyways. So maybe I'll go ahead and write it that way. I'll go ahead and assume, you know, it's going to be, you know, the y is going to be on the left side. So let's just move them to the left. So you know, to move something, you do the opposite. So the opposite of a minus 8y would be to add 8y. So let's add 8y to both sides. Those cancel. It's what we wanted to happen. That was our one move, so let's bring everything down. Now, again, who won by how many? I have 8 positives and only 2 negatives. I have more positives, so that would be a positive. And then I say, well, how many did they win by? Well, again, if you and I are playing a game, and you scored 8 points and I only scored 2, then you beat me by 6. So that would be plus 6y. Those are canceled, so nothing to bring down. And again, don't write 0. You know, that's why we draw the line through it, is to say that it's equal to 0, so you don't actually have to write 0. And then we'll say minus 7. All right, so we moved all the variables to the same side, so we can check that off our checklist. And then now what we want to do is we want to add or subtract. So let's see about adding and subtracting. I want to get all the numbers over here to the right side. See, I'm trying to get y by itself. I'm trying to isolate y. So I don't care about what negative 7's doing. He's on the other side. Oh, and by the way, I need to bring down my inequality symbol. So that would be a greater than. And nothing switched yet, by the way. We didn't multiply or divide by a negative. So that's why the greater than stays a greater than. All right, let's get rid of this positive 5. So the opposite of a plus 5, right, which would be a minus 5. We want those things to eliminate. So what we do to one, we shall do to another. So 6y greater than, if I have 7 negatives and 5 negatives, and this is, I don't think this situation's come up yet. So again, as in sports, a game, as in real life, sometimes there's a shutout. Sometimes one team scores all the points. So if the negative scores 7 points, and then the negative score 5 more points, well, it wasn't that the positives won. The positives didn't score anything. So it had to be that the negatives won, because they scored all the points, and they won by 12. Right? Because they scored a total of 12 points. If they scored 7 in the first half, 5 in the second half, that means they scored a total of 12 points. All right, now, so I want to get 6 out of there. I want to get y by himself. So I added and subtracted, which in that case I subtracted 5. Now the last part is to multiply or divide. So this says 6 times y, so the opposite of multiplication is division. So let's divide. So I'm going to divide both sides by 6. And those cancel. So negative 12 divided by 6, the signs are different. So that's going to be a negative 2. And then here's the question. To flip or not to flip? That is the question. So, well, I don't know. What did we say here? We said that you only switch. So only switch when you divide by a negative. Well, are we dividing by a negative? No, looks like we're dividing by a positive. So therefore, the greater than will stay a greater than. So again, let me repeat that. Why did it not switch? The greater than stayed the same because we only switch when you divide by a negative. Well, I divided by a positive 6, so that's why it stayed the same. All right, well, it's your turn. Give it a try. Hang in there. We only got a couple left. So pause the video here and try number 7 in the middle and number 7 on the right side. Let's check those two in, well, one on the middle, right? One on the right side. Let's check those two problems. So for number 7 in the middle, should have got y less than negative 6. And for number 7 on the right side, should have got y greater than negative 6. And again, purely coincidence there that the numbers ended up being the same. So again, don't read too much into that. All right, so let's look at number 8. And number 8, I do see some parentheses right away. So I know past couple ones we got lucky. We got to kind of skip that first step. But I do see some parentheses here. So I know that I'm going to have to distribute. So hopefully here, you're starting to pick up the routine. You know, a lot of these problems are pretty much the same thing. You know, maybe you have to do one little thing different here or there, but pretty much the same routine. So hopefully you're starting to get that routine down. I circled the 6. I drew my arrow to 2z. I drew my arrow to 5. And let's go ahead and multiply that. So 6 times 2z, which would be 12z. And by the way, multiplication is what we say is commutative, and what that means is that the order doesn't matter. So see, I could say count by 6 is 2 times, right? I could say this, 6 times 2, which means count by 6 2 times, which would be 6 plus 6, which is 12. Or I could say the same thing. I could say 2 times 6, which means count by 2's 6 times. So I could say 2 plus 2, which is 4. Another 2 would be 6, 8, 10, 12. Right? 1, 2, 3, 4, 5, 6. So multiplication, the order doesn't matter, and so that's where we say that it's commutative. So you know, either way you want to count that. So when you're skip counting like this, you think about, well, what, you know, for me, and this is kind of where it's a personal question that you have to answer for yourself, is, you know, what is it easier for me to count by? Is it easier for me to count by 2's? Is it easier for me to count by 6's? I think for some people probably be a little easier to count by 2's. Now this one, because you're not counting too high, right? I mean, 6 plus 6 is 12. That's not too bad. But, you know, let's say we're saying something like, you know, 6 times a much larger number, you know, then maybe that'd be a little easier. All right, so let's come back to it. So 6 times 5, same thing. So count by 6's. Or maybe, yeah, actually, this is maybe a better example of what I was talking about as far as, would you say count by 6 5 times, or would you say count by 5 6 times? Well, I think for most people, they would say it's easier to count by 5's than it is to count by 6's. So if you wanted to count by 5's, that says count by 5's 6 times. Well, so that would be 5, 10, 15, 20, 25, 30. What you can't see, by the way, is you can't see me with my fingers. I'm counting with my fingers. So I'm saying 5, 10, 15, 20, 25, 30. So I'm counting that on my fingers, so that I'm counting 6 times there. So that would be plus 30. So there is no shame in doing a little finger counting like that, right? Because we'd rather you get it correct, than not correct. So I know you might be tempted to, it's maybe a little embarrassing, right? But there's nothing wrong with doing a little counting on your fingers like that. All right, so let's see where we're at. Combining any like terms. Well, I see that I got some z's over here and I got some z's over here. Well, those are on different sides. Can't combine those. 30 and negative 18. Again, I can't combine those two things because they're not on the same side. So let me get that off of there. I can't do that. And this is one of the things. If it helps you, draw it. If it doesn't, if you can just keep track of that mentally, then you don't have to. But you can always draw a line to separate the two sides. So let's get all of our variables on the same side, right? Which is our third step there. So I see z's over here, z's over here. We've already said it doesn't matter which way you go with it, so just pick one. I'm moving everybody over to the left, so I'm going to add 4z to both sides. By the way, you notice on my z's, I put a little line there in the middle. I can't, we're all guilty of this. Sometimes I can't even read my own handwriting. So we don't want to confuse that with a 2, and we don't want to read that as 42. We want to read that as 4z. So that's why you see me just put a little bar in the middle for my z's, so that way I can kind of differentiate or be able to tell the difference between z's and 2's. All right, well, let's cancel out those z's. Add 4z to the other side. We've got our golden rule. Well, if I had 12 of them and 4 more of them, now I've got 16 of them. Bring everything else down, because I'm only making one move per turn. And then I want to add or subtract first. So again, negative 18, he's on the other side. I don't care what he's doing over there. I'm trying to isolate. I'm trying to get z by itself. So I've got two numbers I've got to get rid of. I've got to get rid of the 16, and I've got to get rid of the 30. Well, as we said, we add or subtract first. The number that's right up next to the variable, the coefficient, we always get rid of that last. The opposite of a plus 30, which would be to subtract 30. What I do to one, I do to the other. Bring it down, 16z less than or equal to. And again, notice less than or equal to has stayed the same because I have not multiplied or divided by a negative. So that's why that symbol has stayed the same. Got another shutout. Looks like the negative scored 18, the negative scored 30 more, so they killed it. So they scored a total of 48 points. Now, the last part of this is that I then want to divide to get 16 by itself. So I'm going to divide 16 by both sides. And so what I end up with is z. 16 goes into 48 3 times, by the way. And if you weren't sure about that, if you count by 16, 16, 32, 48, it does go 3 times. If you weren't sure, nothing wrong with doing a little scratch work. Come to the side. You say, well, I think it might be 3. Well, multiply it out. 16 times 3. 6 times 3 would be 18. Carry the 1. Right? 3 times 1 is 3. Plus 1 would be 4. So, yeah, it's 48. So, nothing wrong with doing a little scratch work to check that out. Signs are different, so we know it would be negative. And let's ask ourselves this question. Am I going to switch the inequality symbol here or not? Well, again, it says only switch when you divide by a negative. So I have to ask myself, did I divide by a negative? Well, if I look at that, that's a positive 16. Positive 16. I did not divide by a negative, so therefore my answer would stay the same. So that less than or equal to would stay less than or equal to. Okay, so that's the only thing about inequalities that's a little bit different. If an equation symbol, if you flipped it around, an equal sign, if you flipped it around, it doesn't look any different. So, but if you switch to an inequality symbol, it certainly does. All right, so we are almost there. So number 8 in the middle, 8 on the right side, and then we are to our last problem. So good luck with this one. Pause it, and we'll check back with you in a second. Let's check them. Welcome back. So for number 8 in the middle, should have got z less than or equal to negative 1. And then for number 8 on the right side, should have also got z less than or equal to negative 1. All right. And like I said, if you're not sure about it, then pause. If not, let's finish it up. Alright, so last problem we're going to take a look at, this is number 9. This is you notice what's a little different here is you see these bars. Those bars mean absolute value. Remember that we've said that absolute value represents the distance a number is from 0 on the number line. So for instance, and maybe we'll just do a little side work here real quick. So if I looked at a number line, I'll just put one down, and if I said, well, how far away is 5 from 0? We're like, duh, well, it's 5 away, right? So if I wanted to count how far that was, this would be 1, 2, 3, 4, 5, right? So this is 5 steps away. What if I wanted to say how far is -5 from 0 on the number line? Well, is -5 away? Well, no. Distance is something that we always measure as a positive number. So if I wanted to know how far away it was, it would also be 5 away. So distance is never a negative number, and that's all that absolute value is saying. Think about on your car. If you look at your speedometer, the smallest number on there is 0. You can't drive a -70 miles an hour. And I know what you're thinking, even if you put it in reverse, but no, that doesn't count. Distance is always a positive number. Speed is always a positive number. Nobody lives -5 miles away from school. So all that these bars represent is we represent the fact that sometimes we measure numbers only as positives, not as negatives. Now, certainly you could have negatives. You could have negatives in temperature. You can have negative in your bank account. Hopefully not, but could happen. So there's a lot of situations where we do have negative numbers, but when we talk about speed or we talk about distance, some things like that, you cannot have a negative number. So that's what that bar represents. So what we know is that if we're saying how far is a certain number from 0, what we've said is that, well, the number could be coming from 2 different places. The number could be coming from the positive side, right, which is this right side over here. Or, because see what we're saying with this, when we're saying how far is 5 or -5 from 0, well, it's the same thing, 5 and 5. So we don't know if the number's coming from the right side, or we don't know if the number's coming from the left side, which is where the negatives are. So, because notice if I did this, if I said, what's the absolute value of 5? Well, we said that 5 is 5 away. If I said, what's the absolute value of -5? Well, -5 is also 5 away. So if I said, what number is 5 away from 5? Well, there's actually 2 possible numbers, right? Because we've already have shown that, which is that if I wanted to know what number could possibly be 5 away, well, there's actually 2 answers, because positive 5 is 5 away, but -5 is also 5 away. So there's 2 answers there that would make this true. So in the same way, there's 2 answers or 2 numbers that would also make this true. We just don't know if it's coming from the right side, where the positives are, or the left side, where the negatives are. Now, before I actually solve this, one thing I have to do is that I actually have to get the absolute value symbol by itself first. So you see this +1. So the first thing I'm going to have to actually do there is isolate the absolute value. Maybe I'll make a little note right here of what I'm doing. I need to isolate the absolute value. And what I mean by that is I've got to get rid of that that positive 1 right there. So I'm going to subtract 1 from both sides. And when I do that, I get the absolute value of 5x plus 6 is greater than or equal to 11. Alright, so now this is where it's going to split off into really kind of 2 different problems. So we said that the number, maybe there's a number that's coming from the right side, which is where the positives are. And then that x, he also could be coming from the left side, where the negatives are. We're actually not quite sure which one it is. So what happens, and if you remember on the last test, we had absolute value with equations, very similar to what you have with an absolute value inequality. That absolute value of 5x plus 6 greater than 11, we're going to actually do this problem 2 times. We do it once, we drop the bars off, so I'm just going to write 5x plus 6 without the absolute value bars. And then what it's going to happen is I'm going to write it exactly the same way, greater than or equal to 11. So what you'll notice is that I wrote this exactly, what I do on this side is I do exactly the same thing. So I copied that greater than or equal to 11. It stayed greater than or equal to 11. Now I'm going to solve it from there. Oh, bring back that e. So let's solve it from there. So I'm going to subtract 6 from both sides. So I get 5x greater than or equal to 5. Divide by 5. I get x greater than or equal to 1. All right, so that's one of my answers. Again, we said it could you got two answers here, so that's one of them. Now, what I do for the other side is that I'm going to do the same thing. I'm going to copy it, 5x plus 6. But the only thing that I'm going to do differently here is that I'm going to take the opposite of the positive 11, but I'm also going to switch. So actually, I do two things here. That greater than or equal to would turn into a less than or equal to, and that positive 11 would turn into a negative 11. So let me highlight the differences here before I go further. Is that it started off as a greater than or equal to 11. So the one that's on the right side, you just keep it the same, greater than or equal to 11. The one that's on the left side, you switch it, right? So you switch the symbol, greater than turns into a less than, but then you also switch the number. So the positive 11 turns into a negative 11. All right, so let's solve it from there. So I'm going to subtract 6 from both sides. So I get 5x less than or equal to negative 17. And then I'm going to divide both sides by 5. And I know you're like, oh, hey, wait, I've got a fraction. 5 doesn't go into 17. Well, so we're throwing this on here so you see that it's not always that these numbers will divide evenly. It certainly is possible to get a fraction for an answer, and that's the situation here. So that would actually be a negative 17 over 5. So you'd have x greater than negative 17 over 5, or x greater than 1. Right, so these are actually your two answers there. Okay, and then so we would leave our answer that way. All right, so last question. You made it. Congratulations. Thanks for hanging in there. You've done a great job so far. Let's finish it up. When you finish this problem, then you're ready to retest, and hopefully you feel a lot better about what you're doing because you put in the time to make sure you understand what you're doing. So pause it now, try number 9 in the middle and on the right side, and then we'll do one last final check. All right, welcome back for our final check. I just wanted to clarify. I feel like I may have misspoke on that last one. I just wanted to make sure we're clear on the last answer. That was x less than or equal to negative 17 over 5, or x greater than or equal to 1. And we're using that word or. If we were to graph these on a number line, we would see that they're actually going in opposite directions. So we didn't really get into what's called a compound inequality at this point. Perhaps that'll be a discussion at a later point. All right, so let's check number 9 in the middle, y less than negative 4, or y greater than 8/3. Just to point out on this one, you might have got 16 over 6, but anytime we have a fraction, you want to reduce. So we would have divided top and bottom by 2. So that's how we got 8 over 3. And then we just leave the number improper. Improper meaning that the number on top is the number in the numerator is larger than the number on bottom, the denominator. And the last one should have got z less than or equal to negative 4 over 3, or z greater than or equal to 2. All right, well, thank you for your time. Thanks for hanging in there. Hopefully you found this to be helpful, and hopefully you feel prepared now to take the test. The test that you're getting ready to take is exactly like what you just did. 10 questions. I know there was 9 questions actually on the study guide. There's actually 1 extra question on the test, but you'll see that when you actually take it. But otherwise, it's pretty much the same question. So again, hopefully you felt like this was helpful for you. You put in the time. Hopefully for a lot of us, it's just about a little confidence builder. We have to feel more confident in what we're doing, and hopefully you're feeling more confident by going through this video tutorial. So thank you very much for listening, and thank you for putting in the effort that you've put in, and we'll see you next time. Thank you. Good night, or good day, or good morning, or whatever it might be for you. It's night for me. Anyways, well, I'll stop. All right, bye.